So, did I show you guys how the Starlink works? The difference of the typical satellite communication and Elon Musk Starlink. No, right? Let me quickly show
No,
you.
sir.
Let me quickly show you this. So you can go into Starlink, and under the Starlink, you do have a explanation of how it works. Okay, so let me show you this one. Specifications, FAQ. No, not FAQ. Cool. Terminology. Okay, so it's like this. So there are different types of satellites in the world. Okay, so basically when it comes to GPS satellites, these are geopositioning satellites, which is they are in the upper orbit. Okay, and how it works is you do have a device, and your device can be directly connected to one of these satellites which is there in the orbit. Okay, so how it works is this: you will have a certain set of satellites over you, and how it calculates the location is it basically connects with multiple satellites, and it gives you a triangulation location to find out where you are at. Okay, so there's a set of almost about 24 satellites which is orbiting Earth at one time. A device within the proximity of, let's say, 12 of these satellites will be visible to you. Correct? So you can actually get a clear idea about this if you look at this one. So Starlink, what Starlink does is, see now we do have different orbital levels. Okay, so now what geo satellites are actually basically, so let's say if I'm here, this is the Earth, a geo satellite is literally located at this point. Okay, so let's say if I'm trying to connect with one of my geo satellites, I have to send my location from here, that satellite connection, and it has to go all the way there, and it has to come back. Okay, so see how much time it takes now for a geo satellite to get the data back. See, now that data was sent, still it's going. 150 milliseconds has passed, almost 170. See, that data point is coming back. Okay, so that is how the data is actually sent. So we had a problem. Now this geo satellite communication is really slow, right? Because that is very far away. No, okay, annone athantama gihilla karakila ennone ai me pattara. Elon Musk, what he did was, rawuma gahala enna mati nisa, he sent a set of satellites which will basically orbit the Earth in this area which is known as the lower orbit. So the satellite, now our Starlink satellite is over here, and see how fast the data can be sent back and forth. So the satellite is very close to Earth. You can quickly communicate and send messages back and forth. So see now, usually this geo-orbit satellite will take almost about 200 milliseconds to get one message, and Starlink, since it's close by, it's really fast. But there is, as usual, there's always a but. The but is this is very far away now. Because of that reason, the geo satellite, this guy, can actually cover up much more distance. Let's say I'm over here, and Ethan is over here. Okay, then using Starlink, I have no way of communication, right? මොකද මෙතන ඉඳන් මෙතනට message එකක් යවන්න බෑ, මොකද මූ ඉන්නේ මෙතනනේ. හරි. එතකොට this message has to be sent all the way here, and that can get bounced back. So that's why we have different satellites in different orbit levels. So since the Starlink satellites are in the lower orbit, we can easily communicate. So you guys heard the news that Elon Musk is coming up with a Starlink phone. That's the news thing. So yeah, he's actually coming up with a new phone, it seems. So he's trying to build a phone which will directly communicate with his Starlink satellites. So technically, it's a satellite phone, and wherever you go in the world, that phone will be connected. Now, example is like if I go to another country, when I leave Sri Lanka, I have to enable roaming so that my connection will be connected to whatever the country's network, and then we will be able to communicate. But that's a big hassle because we are piggybacking out of another country's telecom provider, telecommunication provider. No? But when this thing comes up, you just use one connection. That's it. You use the Starlink connection, and wherever you go, anywhere in the world, you are connected. I think if he releases it, it's going to be a groundbreaking device because most of the phone providers will lose their jobs because දැන් හිතන්න මම travel කරන කෙනෙක් නම් මට dialogue use කරන්න ඕනේ නැහැ එතකොට. I can use his phone, and wherever I go, I'm connected. Okay, so GPS works in a similar way. So since this is being connected to these satellites, geo-positioning satellites, we are always specifically connected to the location. That's why this is really fast, and that's why our devices are now intelligent enough to directly connect to these satellites and get this information back and forth. Okay, so that is how the positioning system works. So but this GPS different types of GPS devices. Okay, so this phone GPS device actually works in a different way. That's why depending on the chip's performance, you get different outputs. One time I ordered something on Pick.me, and Marine Drive food shop I ordered something from there, and I think it's something wrong with the Pick.me driver's phone. He was actually coming from the sea. ඩොට් එක තිබුණේ මූද මැද්දේ. ගිහිල්ලා මූද මැද්දෙන් පික් කළා මූදෙන් ඇවිල්ලා තමයි ආයෙත් ආවේ. That was because that his geolocation chip was not properly working. So what we saw was something totally different. Okay, so that's why you have to be careful because since it's anyway depending on satellites, connectivity matters. If something goes wrong, you might get a complete different output out of it. Okay, so that's also a point. Okay, so I hope you guys got the idea. So it's basically 24 satellites. 12 satellites will be always available, and you can connect and take it back and forth. Then we have the television, which is known as the digital video broadcasting, DVB. It's basically an international standard which is basically allows us to broadcast a digital television signal. Okay, so this digital broadcasting nowadays, I think even Sri Lanka is going through a transitional phase where most of the people now actually opt in to use either satellite TV, or we go with digital television like POTV, where it is connecting through either, like if you take dialogue TV, dialogue is connecting to a satellite directly. No? Otherwise, if you take POTV is streaming the video through internet, right? So nowadays we are like most of the time people are opting for that. High quality you get HD content and so on and so forth. But if you take the typical antennas, like if you go with an RF frequency with the TV antenna, then obviously you would be consuming it using this particular broadcasting system. Or at the same time, you have the digital video satellite method. Okay, so what I just explained was the up here antenna that is known as the digital DVB, digital video broadcasting, And we have the method known as digital video broadcasting, DVBS. So that is digital video broadcasting satellite. That is what we have as dialogue TV. Dialogue එකේ වෙන්නේ අපේ තියෙනවා signal location එකක්. So for that particular signal location, we have a broadcasting system which will send the signal to the satellite. And all our dishes, the satellite dishes, should be pointed towards that specific satellite, which then will get the signal back to our house. Okay, so in that way we can consume the frequency and we can directly connect. ඔය මේ දන්නවනේ මිනිස්සු හොරෙන් කනෙක්ට් කරනවා කියලා. Connector boxes දාලා. Have you seen these advertisements? I know, like, there are some people who sell these TV boxes. So there are companies who does this as well. If you search on Facebook, you can easily find there are a couple of companies who basically sell off-the-shelf TV boxes, where you can get the TV box, and when you fix it in, you get a massive lot of channels just by subscribing into the service. It's quite cheap, but since we have a problem, anybody using dialogue TV? Dinal, are you using dialogue?
Sure.
Dialogue TV?
Yeah.
Okay, perfect. So most of the TV channels are coming from India, right?
Yeah, some of them, sir.
Some of them, but like about 90% of the time, even if you take Discovery and Sports and all the channels, they are literally coming from India, because we are accessing one of the Indian broadcasting services. That's why we get the Indian version. Now when you go to a different country, let's say if you go to Singapore, and if you open up their version of Discovery, it's completely different, something totally different. So because they do get the broadcasting from the Asia Pacific region, so that they get a different version out of it. Okay, so depending on the location, what you get is differs. So you guys all know what this is, so you obviously might have seen this in multiple houses. So you basically set this up, and Dinal, have you seen how they set it up when they came to your place to fix it?
No, sir.
Okay, so they actually bring a laptop and they plug it into the antenna itself. Okay, and then in that laptop they have a calibration software which will basically show where to point the dish. So one person, so let's say if you fix it on the roof, one person climbs to the roof and stays there, and another person stays with the converter box, and he checks the calibration. Until the signal is perfect, they adjust it. Then only they keep it there. So that's why if your signal is not properly working, you can give them a call and they basically come and calibrate it again. So based on the satellite location, you set it into that particular location so that the data will be downloaded from there. So that's the way it works. Okay, so then there are a list of new broadcasting standards as well, which is known as DVB-S2 and DVB-S2X. So these are new digital broadcasting standards where now they gave us the ability to stream high definition, HD. So when Dialog released this long time ago, no? So back then they did not had HD capability, but now, since the advancements of the technology, now it allows you to go with HD. Now you can actually stream high definition content, as well as you do get some interactive services as well through the internet access. So interactive services and internet access. So now when I say interactive services, you have this when you go through the dialogue TV box or PEO TV box, they actually allows you to like play around with the like download, not download, watch paid content, right? In SLT PEO TV box, you have this. I can't remember the name of it. There's a specific portal where you can actually watch paid videos. You need to pay in order to download the video, and you can watch it up to a certain time period. So all these features are based on these two technologies. So just keep in mind, if you're highlighting it on the document, highlight it. So the televisions, they work on digital video broadcasting, DVB, and we have DVB-S, which is this which stands for satellite. And on top of all these, we do have two different versions for DVB-S2 and DVB-S2X, which are different broadcasting systems which allows you to connect for HD content. Then satellite phone, as I explained earlier, so satellite phone works the same way. You are directly connecting to a satellite, which is a communication satellite, which is in the low orbit, which will allow you to connect and consume transfer data. So remember, these phones are bulky because they have these huge antennas and communication, so that they can directly connect. Then when it comes to the military also, military actually, that is something similar where you basically contribute to most of the satellite communication. They they use different types of satellites for different types of communications. Then give me 1 second. Hold on. Yeah, so just to do a recap, I'll quickly go through this. This is something which you guys all already basically gone through, and so in basic terms, then broadcast communication, we have the analog TV, the television, and the radio. So this is again a similar transport communication method where we basically use radio signals to communicate and go through the analog signals. So you have the UHF antenna. So we do use the antenna, and using the antenna, the television or the radio can basically receive the signals. So at the same time, now we have the digital television DVB-T. Okay, so this is actually known as the digital television. So this is a method where actually transmitters are based on the Earth rather than orbiting. So this will basically allow you to transmit the signal within the location itself. Okay, so you guys might have heard this. Now Hiru and Derana, they boast about high definition TV, right? They say Hiru is the first HD TV channel in Sri Lanka, and all. It all depends on this transmitting technology. So this DVB-T2 is basically a new standard which provides much more functionality, which in return gives you the high definition television service. So still that is getting transmitted using this normal analog signals, but then again the new system allows you to actually go with a digital signal. Apart from going with the typical analog signal, you have the option to go with a digital signal, which then if your TV supports this, then they can receive. Okay, how many of you have radios at home? Do you have a digital radio? Ethan, do you have a
No, sir.
digital radio? None. Okay. Do you listen to radio on your phone? No. iPhones වල කොහොමත් නෑ radio එක. Okay. So okay. Even in your cars, your parent cars, you have a radio now. So in those radios, have you noticed that they can show the name of the radio channel? Have you noticed it? The name of the radio channel is visible. Ayyo, එක පේනවානේ. Okay, you can see it. So okay, so back then radio signals were also actually using analog signals, but now if you turn on a radio, you can actually see the radio channel. So when you tune in for a radio, that particular a certain set of information, digital information, is being sent through the frequency. So example is I always listen to Kiss FM. It is 96.9, and when you tune into Kiss FM, in my car radio, I can see the name. And sometimes depending on the program name also appears. So that is part of the digital radio system as well. So this is what we are jumping into next. So this is known as digital audio broadcasting, DAB. Okay, so in this case it actually allows you to, it's similar to the previous broadcasting method, but it allows you to send some data which then it can display. Okay, so this data can have text data including the time, the name of the station, and also sometimes the name of the music which is being played. Okay, so I think nowadays most of the time radios are not being used that much, but I believe in cars and like vehicles, people opt in to use radios because then you can like connect to it without having an internet connection. So remember the word. So if you are highlighting it, please do highlight this point. So DAB is used in Europe and Asia, but the important point is DAB allows you to transmit textual data. Okay, so when you are transmitting textual data, that means you can show the name, title, and the song, and whatsoever the data which is being sent from the radio broadcasting station. Okay, so then we jump into wired communication. We have discussed few points before as well. So wired communication. Now when it comes to the type of data which we send through wires, it can be a variety of data. It can be video, it can be digital audio, it can be some analog audio, as well as it can be a storage, it can be some storage data, plus it can be networking data, right? So let's quickly check what are the types we have. So like if we take so like here you can see a list of items. So if you take HDMI is basically digital data, right? So HDMI allows you to send a digital video signal. And is it only video, HDMI? Does it send audio as well? Okay, let me ask Kunal a question. When you plug in your PlayStation to your TV, have you tried controlling the PlayStation using the TV remote? Has it worked? No, I didn't get you. What is the TV you have at home?
The Samsung.
Samsung. Okay. Is it a like what's the generation of it? Do you know the generation?
No, sir.
Okay. So I'm not exactly sure about Samsung. So I had a LG TV, LG, just a normal LG smart TV. And in that TV, there is a specific port called, she. I can't remember the port name. That's an HDMI port by anyway. But that HDMI port actually has a specific data support. Okay. So when I plugged in my PlayStation 4 Pro, and when I turned on the PlayStation, you can control the PlayStation menu using the TV remote, because the TV communicates, opens a digital link through with the PlayStation, and it allows you to control the menus. So you can literally turn on a game without even touching the PlayStation controller. ඕක මට මේ ඕක හෙන කනාවට තමයි ඕක හොයාගත්තේ, because I one time, like some time back, I plugged in my PlayStation and I turned on the TV, and when the PlayStation menu came up, I was just navigating through the remote. TV remote එකෙන් මෙහෙට මෙහෙට කියලා navigate කරා. ටික වෙලාවකින් තමයි තේරුනේ අඩේ මම TV remote එකෙන් මේ කරන්නේ කියලා. So I also didn't know that I can do that, but after I was navigating only, I got to know you can do it. So it's actually quite good. So you do have a specific port. Just check in your TV. Next time when you plug in your PlayStation, just check in your TV. There should be a dedicated port which has that digital link. So then the TV remote and the system can communicate together. So this, keep it in mind. So here it just says HDMI is for digital video connections, but no, HDMI has a data transfer port as well, where you can actually use it to send and receive data. Okay, and then we have SPDIF. So SPDIF is for digital audio connections. Have you guys seen a SPDIF port? දැකලා තියෙනවද මොකක් හරි එකක?
No, sir.
සෙටප්ස් වල දැකලා තියෙනවද රතු පාට චූටි ලයිට් එකක් පත් වෙන පෝට් එකක්? රතු පාට ලේසර් එකක් වගේ ලයිට් එකක් පත් වෙනවා. නෝට් කළා නැද්ද?
No, sir.
Okay. In the old PlayStation, we had it. The original PlayStation 4, we had a SPDIF port. I'm not sure PS5 has it. No idea. So SPDIF is actually a digital port where you can actually connect to a sound system. So you connect your subwoofers and all using SPDIF. So then that will automatically create a digital audio link. Okay, and then mini jacks. You guys know what is a mini jack is. We use mini jacks for audio and headphone jacks and all sorts of things. Plus USB is for the storage, and Ethernet, of course, it's for the networking, right? USB, you can actually transfer data. So then we talk about wireless communication. So wireless communication, we have Wi-Fi. So Wi-Fi is basically a wireless communication technology which will allow us to send and receive data using a specific hub, right? So you guys really need to remember this particular term, which is known as the Wi-Fi specification. Okay, so why do we need specifications? Specifications are primarily there to list and create a specific, let's say, a standard. Okay, so when it comes to any sort of a technology, there's a certain set of standards which has to follow up. So this IEEE 802.11 is basically the standard which is behind the wireless communication for Wi-Fi, and these standards are getting different revisions. Okay. Okay. For people who are using POTV and SLT fiber, give them a call. If you don't have a 5th generation router, you can actually give SLT a call and get the new router. The 5G, for not 5G, I mean the not the mobile 5G. This is the 5th generation Wi-Fi router, which can actually give you close to about 300 to 400 megabytes per second transfer rate. Usually our routers can go up to about 30-40 megabytes. No? This can take up to about 400 megabytes. Okay, so the difference between that is the generation. Okay, so we basically get different generations, Wi-Fi generations, and they do get different numbers as well. And as the technology improves, the performance and the power also gets improved. Okay, so at the same time, these newer technologies actually introduces much more what do you call it, range improvements as well. So with the new technologies were there, they actually gave new they increased the maximum range which you can actually go through as well. Okay, so that is about Wi-Fi. Then we talk about Bluetooth. So Bluetooth, yes, it's simply a simple wireless technology which you can use to communicate between two devices, right? And remember the point, short distance. Okay, so please do highlight that. So Bluetooth is a type of wireless connectivity that lets devices connect over short distances. Okay, so short means not that short, but yes, it's short, not like Wi-Fi. Okay, so how it works is you can connect two devices using the same interface, but there is a point, it cannot carry as much as data as Wi-Fi. Okay, so there is always a small, it is basically created for small range communication. So how it works is, it will basically communicate with two devices and it will connect with each other. And as you guys might have tried, if you take a mobile phone and if you try to connect that mobile phone with another device or with your laptop, you have to first pair them together, right? So Bluetooth works as in a way. Now Wi-Fi, you use a password to log in and you authenticate, but in Bluetooth it works as pairing. So you basically request. So if let's say if I'm pairing my phone with Ethan's mobile, then I first need to see Ethan's mobile active, and then I have to send a pair request, which will be sent to Ethan as a message, and Ethan has to approve it, and then these two devices will be connected together. Once it's connected, we have an open data stream which we can then start sending data. But there's a problem. This data is not the maximum number of data which you can send is not much, so it is limited. So because of this reason, we still use this for a lot of devices which will basically communicate with each other with small data footprints, similar to mice, keyboards, headsets, right? Even like high-end devices and portable speakers, or all these Bluetooth speakers are there, and all these things, they do not need high speed data transfers, so they connect using Bluetooth. And you guys know what? Now, I recently got to know this, but apparently that was there for some time. But nowadays, these JBL speakers, now they come as Wi-Fi enabled speakers. I recently saw this advertisement where you can actually earlier, like most of the speakers are still, they are connecting through Bluetooth, no? But now you have this JBL Charge 5, one of the latest models, which directly connects to a Wi-Fi. So technically you can place the speaker any location, anywhere where you have a Wi-Fi connection, and you can actually play Spotify on remote. So I really need to try that out. I still couldn't find it. I want to buy one actually, where you can so you can keep the speaker at any locations. You don't have to worry about Bluetooth. And then since the speaker is connected to the internet, you can actually see your devices on your Spotify account. And then I can immediately play whatever the song I want. So basically, I can keep the speaker at home and play a song from here. Okay. So that's interesting. So yeah, so I just told that because you guys then can understand the limitations of Bluetooth and Wi-Fi. So if you do a quick comparison, Wi-Fi, yes, the range is high. You have long range, and Bluetooth, obviously short range. And bandwidth wise, yes, again, Wi-Fi has high bandwidth, and Bluetooth, the bandwidth is limited. And power, Wi-Fi takes a lot of power, right? So the power usage is very high, and Bluetooth, the power usage is extremely low. So that's why we use Bluetooth. Okay, so if you have used a Bluetooth keyboard or a mouse, you might have noticed like they last for a long time. I do have a Bluetooth mouse. I think I have charged. I've been using this for about two plus years now. I think I can remember the number of times I charged it. I usually charge it about once in 3-4 months. It just, that's it. So the battery life is really really good, and it lasts for a long time. Okay. And then security wise, yes, Wi-Fi has high security, but Bluetooth, we can't say it's low in security, but the problem is the pairing process can be hijacked. Like you can pair with someone else, and if you let them access your account, then you directly let them in. And then can connect to multiple devices simultaneously. Yes, Wi-Fi, you can connect to multiple devices, but in Bluetooth, you are limited. Okay, not impossible to connect, but the number of devices you can connect is limited. And also keep in mind, depending on the Bluetooth device, guys, you have limited connectivity. Example is, if you take a Bluetooth speaker, they do have a limitation of number of devices which can be connected at once. Okay, so there is a restriction for this. Okay, and then we have another term. So iPhone users, we call it AirDrop, and Samsung also, now I'm not sure the exact word, but Samsung also now has a method of just sharing from tapping the phone, right? They came up with a method, they have a method of doing this. So that
Quick share.
Samsung, quick share.
Yes, sir.
Okay, okay. So now in iPhones we do airdropping, then Samsung has that sharing feature. So they all use this method called Wi-Fi Direct. Okay. So Wi-Fi Direct is something similar to Bluetooth, but not, sorry, something similar to Bluetooth, but it works in a different way. So it's a low power version of Wi-Fi which can actually connect two devices together directly over a short range. Now let's say if I'm going to send a file to Dinal, I would be like standing next to him. So if I'm trying to share something with you, what happens is these guys, they do have NFC sensors, near field communication sensors, and when I tap my device with your iPhone, this automatically creates a connection between us. So it's a Wi-Fi connection, but it's known as Wi-Fi Direct. So what happens is, once this connection is established, I can directly send you a file because we are using Wi-Fi. That's why AirDrop is really fast, because let's say if I create a video, if I record a video of like couple of hundred megabytes, I can just drop it just like that, and you will receive the video over the Wi-Fi Direct extremely fast, and just like that it works. Okay, so since it's short range, it works in a different way. So this is something extra, but just keep in mind there's a technology called Wi-Fi Direct as well. Then we talk about the different generations of mobile. Okay, so 3G and 4G. So this is basically, this is basically the type of connectivity which we use for mobile broadband. So for the moment we do have 5G, but still not exactly 5G. What we have is something known as 4.5G. So it's 4G but 5G. Okay. දෙකටම නැති තැනක අපි තාම ඉන්නේ, but yes, at some locations you do get access to 5G. So how it works is, so the G stands for the generation. Okay, so that means 4G is basically the fourth generation of broadband, and now we are in the verge of getting 5G. So this is basically the technology, the mobile technology which we are using, and 5G is actually getting, let's say, rolled out in most of the places. I think most of the places in Colombo now we have 5G, as well as it is getting rolled out in other areas as well, but it will take some time for us to completely move to 5G, because there's a certain point behind it. So we don't talk about this in depth, but just to tell you guys a small, like a brief idea about it. So 4G, so first generation, second generation, third generation, and fourth generation. How it changed was, it was based on the signal length. So now still, as we take, if we take third generation and fourth generation, the difference is you have different signal lengths. So based on that, the range and the number of data, or the bandwidth we can send is different. Now 5G, what happened is, 5G is much faster. Faster means not fast, but the bandwidth is higher. But the problem is that signal strength is also very dense. Okay, just think that it's kind of like a big water stream. Okay, so since the signal strength is dense, it does not travel very long. So that's why we still have some specific 5G hotspots, where in those locations you have good connections, but if you go out just like that, you get switched back to 4.5G, but 4.5G or 4G. So it all depends on the speeds and the location, but I believe in some time it will obviously go out. Okay, then we talk about infrared. Okay, so infrared is known as IR in simple terms, which is basically a light which will carry a certain set of information through a short range. Okay, so let me show you guys something interesting. I hope I have enough battery. Okay, so I have my Raspberry Pi here. Sorry, this not the Raspberry Pi. My give me 1 second. Let me show you something related to infrared. So I have my Flipper Zero, so I can show you guys something. So infrared works in a way. Now here I do have an infrared emitting device, which is this guy, right? So how it works is that so here I do have an option to basically load couple of remotes. Okay, so let me load up a remote. Okay, I'll just go with a universal remote, and if I send something, can you guys see the light? No, right? No, it's not visible. No. Yeah, so for this particular camera, it's not visible. So ideally what it does is, this actually emits a specific light sequence. Okay, so this light sequence is the sequence which is getting emitted can be read by the device. Okay, I will show you guys a different example. So this is known as a infrared scope. Okay, so I do have my AC remote here. So if I, let's say, press one of the buttons, okay, so you can't see anything which comes out of here, right? So, but this is literally emitting a signal. So, but this is known as a infrared scope. So I hope it is visible. Okay, so now the screen is empty. Okay, now what I'm going to do is I'm going to, so this is the reader. So I'm going to press a button in this remote at the flipper 0 to capture the infrared signal which is getting sent. Okay, so this is the sensor, and I'm going to place it here, and let me press a button. So immediately when I press a button, you guys saw the data set. So this is the data set which is getting sent through the remote. So when I press it again, should be able to, let's say if I press something, yeah, it's locked. Okay, let me clear it again. Okay, so IR scope. Okay, let me do another action. See, right? I hope you saw the blue color button. So see, this is all these dots in the screen. So these are literally signals. The signals which is getting emitted. So it's almost similar to a binary frequency. So this has a particular binary frequency, and it allows you to send it out. I'll show you guys a fun fact. So now I can actually, so in this flipper 0, you do have a feature called learn. Can you see it? You have a feature called learn new remote. Okay, so this is how it's going to work. So if I activate it, see, it basically shows you how to get the data. Now see, the blue color light is flickering, so that means the flipper is actually listening for the signal. Okay, so let me send him a signal. So let me change the swinging on. Okay, perfect. So now it says unknown, but what I did was I pressed the swing button on the AC, and I just saved it. Now this guy can actually send it. So if I press the send button, that would get sent out. I'm not sure whether you guys can hear the sound of the AC, but see, hope you can hear the toot sound. Okay, so with this thing, actually this is kind of like a hack, but you can actually hack into infrared and save the frequencies. So see, now the reason I wanted to show you this was, it is not actually that secure, right? Because wherever the frequency is going back and forth, you can easily capture it. And since it's being infrared, IR, and light, you can basically track it and keep it saved. Okay, so that's how this IR works. So as I showed you guys, it basically transmits a sample, a binary sample, which then the device has a specific registry saying this particular sample should do this particular action. Right, guys? Once you get it done, you get full access. Perfect. Okay, I hope it's clear. Okay, now we talk about near field communication. So we talked about this some time back when we went through the digital devices, where we talked about the RFID chips. So it's almost the same thing. We have the radio frequency RFID, radio frequency identification chips inside these devices, where it will be basically used to do payments and cards, do credit card payments and mobile transactions, and so on and so forth. So what it does is it basically reads the ID, and it goes through to, it basically reads whatever the data which this emits, and it saves in the system. Right? It's quite straightforward. you just get the information and save it. So we'll quickly go through few items when it comes to the wired and wireless, to just to do a comparison, benefits and drawbacks, just to understand what is good and what is bad. Not basically why bad, good and bad, but what can be used and where it can be used and how effective it is. So when it comes to wired and wireless, cost point of view, yes, wired is cheap because you can actually purchase wire for a small number of devices and get it sorted out. But in the other way around, wireless doesn't cost you anything for cables, right? And but you might need wireless access points to extend your signal. Okay. Now example is, now in my home I use SLT internet, but the problem is that particular router's wireless signal is not strong enough. So because of that reason, I have another access point which extends the wireless signal. So I know that's a bit of a hassle, but then again, that has to be done because otherwise I don't have full access to the Wi-Fi network throughout my home. Right? So you get that type of restrictions when it comes to wireless. And when it comes to safety, yes, risk of tripping over cables, that is of course there, but I think that's not a very bad risk. But then again, yes, but wireless, nothing. So it's basically wireless, so it will go through anything. But at the same time, as this also mentions, some people are actually worried about these effects of the radiation. So I'm not going to tell you the names of those movies, but there were couple of movies which was actually, some of them were shot in India also. There were a couple of Bollywood movies also which talked against the 4G networks. So some people say that 4G, I'm not sure, I'm not taking any sides, but some people say that scientifically they can prove that 4G is, the 5G network is bad for humans, as well as some say, since that signal density is high, that affects birds. So they say that because of the 5G towers, some birds cannot actually navigate and find their paths because of that frequency or that radiation. I'm not sure, I haven't done any research on that. But yes, that was there on the news for some time. So people were actually giving some backslash for 5G connections. So yes, that is also there. So then speed wise, yes, obviously we know that wired is much faster, because then again it's electricity moving inside wires, so that's straightforward. And speed wireless is slow, obviously, right? Compared to wires, it is obviously slow. Then stability, wires are less prone to have issues because it's basically direct connections through wires, right? But so it doesn't affect that much, or you don't get that affected that much. But wireless, yes, wireless can be affected by different types of interferences, objects, buildings, and multiple different types of let's say events also. Like example, if I know, like dialogue TV, වහින්න ගත්තාම සිග්නල් නැති වෙනවා නේද? වැස්සක් එනවා කියලා කියන්න පුළුවන්. We used to use dialogue TV long time ago. ඒ කියන්නේ වැස්සක් වහින්න එනවා කියලා කියන්න පුළුවන් TV එක ගන්න නැති වුණා. වහින්න විනාඩි 20කට විතර කලින් TV එක යනවා. So like most of these sometimes it can be geographical factors, sometimes it can be natural factors, sometimes it can be due to a building, so and so forth. So there are different factors when it comes to which can interfere. Portability wise, Not portable. Wires are not portable. You cannot take anything which is connected to a wire from one location to another without moving the entire structure. Huh? But wireless, it's basically portable within the signal range. So remember, this is a keyword. So it is portable, yes, but within a particular signal range. If you go off the range, then no, you are done. Okay, and then mess would be can look untidy if lots of cables are used, yes, but wireless is obviously tidy because you don't have to worry about cabling. And security wise, wires are more secure. I mean, the most secured way, because let's say if I want to hack Dinal's network, if Dinal is using all wired networks, then I will have to literally have to like find a way to get into his house, and then I'll have to tap into the wires, right? I'll have to find the router, plug in a cable and connect. But if I am to hack Dinal's Wi-Fi network, then there are ways where you can actually launch few attacks and try to find out and try to get into the Wi-Fi network. If I get into the Wi-Fi, if I got into the, sorry, when I get into the network, I have full access to all the devices within that network as well. So that is why we say that to be careful when you join your device to a public network. So example is, if you go to a cafe or to a supermarket or some sort of a location like that, you are offered the option to use a public network. So yes, free internet ne කියලා ටක් ගාලා connect වෙනානේ. But the problem is most other people most of the people will be using it, and you might can get exploited by someone else. If somebody wants to launch an attack, yes, they can do it. Okay, and then last point, maintenance. So maintenance, that is since it's being used by cables continuously, long periods of using it, there can be damages to the cables. I'm not saying it will, or we are not saying it will, but using these ports continuously, sometimes it might damage. Now example is at my office we have this problem, since some of the cables and some of the connectors, since they have bronze leads, they basically get corroded after some time. So then what happens is, your connections, since the cable is plugged into a computer, that connection fails. So most of the time we have to replace the cable ends time to time basis, to just to make sure that the connectivity is properly there. But when it comes to wireless, technically there is no maintenance, because once the system is up and running, it works. And until if something breaks, it goes down. Otherwise, yes, you have a proper connection. Then we talk about, so that is about the wireless connectivity. Then we go, finally we have the point about broadband, mobile broadband and cellular networks. So now, broadband, mobile broadband and cellular networks are basically based on a specific internet service provider, right? So we have multiple different providers now. Example is, we have Dialog, which Dialog has Dialog Internet, Dialog Broadband, and this broadband is based on either the mobile network, or they do have a different type of broadband which is being given to us by fiber optic cables, right? So earlier SLT was using ADSL, which is again another system of getting the internet, but now we do have the fiber optic connections, which now we get broadband access. And recently Dialog also started giving, Dialog also started giving broadband fiber optic connections for home users. Dialog was already in that market for a long time, but they did not actually give that to home users. But now they have changed it. Now you have the option of getting it. So anyway, the broadband means basically accessing internet through a connection to an internet service provider, right? And they will be either using the mobile networks to access this internet connectivity, or they can use fiber optic or copper cables to basically a copper cable network to access the internet. So anyway, just to highlight the points, mobile broadband networks provide access to the internet through an internet service provider, and that would be the explanation. Okay, so just keep in mind, guys, so we do have a certain set of keywords. So ISP is the shorthand word for internet service provider, as well as we have the fiber optic cables. I have shown you guys what is this cable is when we went through this undersea cable part, as well as a copper cable is basically, in this case we call copper cable, in this case we call this telephone cables as copper cables. So they are basically a cable which will basically send data using electrical signals, which is conducted through copper. අපේ phone connection එකක තමයි. ඉතින් ඉස්සර before we got this fiber optic connections, we were using ADSL. So ADSL was basically sent to our home through our phone lines. So ADSL had a different okay, before that, if you go like early 2000s or late 1998, 1999, during that time we connected to check our emails and all. So we connected through the modem, and that modem was actually using the telephone line. So literally, when you had to connect to the internet, when you had to connect to from the email server to download the emails, we had to dial a number. I can't remember the number right now, but that was something like 0112 and 82123, something like that. So there was a number where you basically dial through the modem, and that will connect you to the mail server. So, and later on then the internet was introduced. By that time also we call it the dial-up internet, and the dial-up internet also used a similar way, where you had to dial a number, and that number connects you with the internet server, and then it allows you to establish a connection. So all this time we were using the copper wires, and then we had ADSL, which is still using the same thing, but the connection method was a little bit different. So your phone was not technically dialing; you were connecting through a different protocol known as ADSL. Yes, and then only we were introduced with fiber optics. So now you guys have fiber optics and 4G connections. Now we don't actually go back to that era. Okay, so from that point we actually wrap up the communications. Okay, now we can jump into networks. So networks, we do have a few set of learning objectives, and here at this point we will be actually learning about how and why, how our devices are connected to a network and why we have these different protocols. Okay, and we'll be talking about ISPs, their roles, and different types of networks, and so on and so forth. Okay, so with that, we'll be actually talking about few more points about data backups and shared softwares, and do you guys use peer-to-peer softwares to download content, download movies and all? මොනවද use කරන්නේ? Have you guys have you used torrents?
No, sir.
බෑනේ කොහොමද games and softwares ඕගොල්ලන් download කරන්නේ? Okay. Okay, so I'll show you guys few things then, but I'm not advising them. I'm not advising anything. I will just show you to educate how these things work. Okay, so first of all, we have to talk about requirements for connecting to networks. Okay, so why do we need to connect to a network, and what are the primary requirements? So when it comes to connecting to a network, the primary point is there's a certain thing called protocols. Okay, so the word protocol means that it's a set of rules which or that will allow the exchange and transmission of data between devices. Okay, so protocol කියන්නේ ඇත්තටම අපි සිංහලෙන් කිව්වොත් protocol කියනවා ඕනෙම rule එකකට. Okay, so similar to that, in this vocabulary term we call a protocol a rule. Okay, මොකක් හරි rule එකක් මේක connect වෙන්න තියෙන. හරි, okay, let's see how it works. So in your Windows PC, you do have the option of networks, and when you go into networks, you might see, so this is actually something a little bit older, but you might see all the networks listed down in your all the available networks which is connected. Okay, so we have this thing called network operating systems. Okay, so network operating systems means a network operating system means basically this will allow computers to connect or communicate on a network which is already created. Okay, and it actually provides additional functionality to a stand-alone operating system. Okay, so stand-alone operating system එක කියන්නේ අපේ දැන් ඕගලන්ගේ Windows එක ගත්තොත් the operating system you are using, that is a standalone operating system, right? You have that installed and you have it running on your PC. But we have this thing called network operating systems. ඒකේ වෙන්නේ similar to your main OS, but it gives you much more features. So okay, තියෙනවා architectures ගොඩක්. We don't use them anymore, but there are some architectures now. There's this system called having a mother computer or a base computer and dummies. Okay, so it's like this. So you can actually build a server and you can use dummy machines. Dummy machines means it's just a machine which is connected to the internet. It does not have any sort of a hard drive or anything. So how it works is when you turn it on, that or the child machine will get connected to the mother machine or the parent machine, and it will pull out the operating system and it will work on that. So this was an architecture which was there some time back. Now we actually don't use it, but what we use now is we go with the network operating system where it's like this. So let's say if Asman, Dinal and Ethan all and me, all four of us are working at an office, let's say, and then in that office, let's say we need to have some security protocols or security validations. So every time when somebody logs in, we need to have some protected data so that information can be specifically kept inside the network. Then we can have something similar to a network operating system, which is also what we call as a user management system. So there will be a server which will have all our user accounts, and when we turn on the PC, what we do is we connect with that machine. Okay, and then that machine is managed by, let's say, a network administration, some sort of a network administration, and there can be a certain set of network administrators which will be in charge of that. So they will give specific permissions. So that's why this says passing username passwords to the server for checking when a user logs in. It's like this. Okay. අපි හිතමු මෙහෙම මේ අපි ගමු මම let's say I'm doing marketing and Ethan is a developer, Dinal is doing sales, and husband is in the management, right? So we all might need different access levels. Let's say as a marketer, I might need access to something else, and Ethan, since he's a developer, he might need access to a certain set of features, but he might not need access to see my marketing details. And husband, since he's in the management, we all shouldn't see what he's working on and his documents, right? His accounts and whatever the files he's in charge of. Then to give that as a, so to solve that problem, what we do is you go with this type of an architecture where all of us will have individual permissions allocated to us from the admin. Now let's say මටත් ඕනේ develop කරන්න, so I want to join Ethan's team. Then if that happens, then I can actually contact the administrators and I can say, hey, give me permissions to access Ethan's files, or give me permissions to access the code base to start developing. Then they can provide access to whatever the network storage resource which is controlled by Ethan. So ඕක හරි complicated කියන්නේ මේ now different offices can, depending on your requirement, you can scale it up or down. Then at one of my previous offices which I worked, it had over 100 employees and we had like we had like close to about 9 or 10 teams. So each team was working on a different project and nobody needed access to see someone else's work. So that so the network team, they designed it in a specific way. Inside the office, we will be learning all these things in the coming points. So inside the office, what they did was they created something like subgroups, and then each subgroup had a team lead, and in that team lead's account, they had the option of providing different permissions. So let's say if we are a team, and I'm the team lead, I can give what permissions I want to Ethan, Rinal and Nazman. And based on the permissions I give you guys, you have specific access. Is that highly lazy? Then manage can now. Let's say if we get a new person into the team, I can still create them an account and create a specific permission role, so that that particular person will have access only to that particular set of details. Interesting way, and in that way you get a lot of control. At the same time, you have access to the network also. Then example like office we had a printer, local printer, something like a photocopy machine, which was connected to the internet. And even with all these restrictions, we were still able to connect to the printer and send a printout also. So I know it's a bit of a complex setup, but that allowed us to have seamless control over throughout the entire system. Okay, so that's the idea behind a network operating system. So now there are few ways you can use to identify a device in a network. Okay, so I will, give me 1 second. Sorry. So we have primarily, we do have three methods of identifying a device in a network. So primary method is IP. Then we have something known as the MAC address, and we have something known as the device name. Okay, so let's go through it one by one and understand how it basically works. Okay, so the IP, the Internet Protocol. So, Rina, what is an IP? Do you know what's an IP is? IP address කියන එක අහලා තියෙනව නේද?
Yes, sir.
Yes. Where have you seen it?
Like the house address?
Your what address?
Like,
නෑ හරි කොහෙද දැකලා තියෙන්නේ IP address එක?
I haven't seen one.
අයියෝ, you should have seen an IP address නේ. In your machine also you
I probably have seen it, I forgot.
forget where. Okay, that's true. That can happen. Okay. So, what about Ethan? Have you noticed an IP address at any point?
No, sir.
Hardly. Okay. So in simple terms, IP address is basically a unique set of numbers which is used to identify your device. Simple as that. So when it comes to a network, your device need to have something like an address. අපි නිකන් example එකකට හිතන්න මේ let's take a big apartment complex. So in this apartment complex, we have a lot of different apartments, right? So each floor will, let's say, each floor has 50 apartments. Then the numbering would be something like, depending on the floor ID, we'll have an apartment ID, right? අපි සාමාන්‍යයෙන් හොටෙල් එකක ගන්නකො හොටෙල් එකක ගොඩක් වෙලාට නම්බරින් යන්නේ number starts from 100, 200, 300, 400 and 500, right? Likewise, so if it is on the first floor, number starts from 100 and 101, 102. Likewise, if it is on the second, let's say if it is on the fourth floor, then it would be 400, 401, 402. Likewise, right? So that is to identify the floor and to identify the room, right? I හතරෙන් පටන් ගන්නේ fourth floor එක කියන්නේ. IP addresses also has a similar method of identifying your device. Okay, so let's check this particular set of types of IPs we have. So primarily we have two IP groups, which is known as IPv4 and IPv6. Okay, so IPv4, just by the looks of it, it's actually easy to read. Okay, so you just have four sets of numbers, which will be separated by a full stop, a dot sign, right? So by default, this is basically a number which will have four sets of numbers, 192.168 and 1.1. Okay, so this is basically the 192.168.1.1 is actually a universal default for the base IP address of a router. Okay, so you guys can try out something. Can you open a browser and take a new tab and type 192.168.1.1 and see what happens. So if you are using a dialog router, you should get the router's landing page. The router has a inbuilt operating system which is running, and you should get that page. And if you have a SLT router, something similar to an ZTE or some sort of a router like that, then you will get the landing page of that particular router, so that you can log in and see how it works. Okay, so that's the basic base IP address which is we use on universal basis. Then we have the IPv6 which has 8 groups of 4 hexadecimal numbers, okay, which is separated by colons. For example, if you look at this one, you can see this is a full IPv6 string. Okay, so what happened was actually it's something interesting. Okay, so IPv4. So we were stuck with IPv4 for a long time. So IPv4 has a limitation. Okay, so the thing is, since we have 4 points, 4 stops, that means there is a certain number of device limitation which we can actually go through, right? So because of that reason, it was basically created at the beginning to support over almost about 4 billion devices. But what happened was with the advancements of internet, we are in the process of running out of IPv4. So technology, as the evolvement of the technology, now we have IPv6 as well, where now with IPv6 we can go up to an unlimited limit of devices. So we'll talk about this calculation part in a while, but let's just understand the basic theory behind this. Okay, so now how this works is, now the IP address, the IP address එක තිබුණට නැහැ, somebody has to allocate it, right? So now when you connect to a device, what happens is your device, your router, then let's say if you are using a dialog connection like a 4G connection, you have your dialog router. No? Otherwise, if you are using something like a SLT fiber optic connection, then you have your SLT router. So what you do is, when you connect to your router using Wi-Fi, simple sentence, what it does is it will tell the router, hi, I need to get access and I need to connect to your network. Okay, so your device is basically sending a message saying hi, and your router has a system which is running in the router's app software, which is known as a DHCP server. Okay, in terms, it is known as Dynamic Host Configuration Protocol, DHCP. So keep this highlighted. You are going to get that as a question for sure, because it might ask you what is DHCP. So what it does is, you send a hi and the DHCP receives that hi, and DHCP, what it does is, DHCP says, Hari, okay, Elekiri, welcome to the network, you can join, and this is your IP address. So the DHCP gives you the IP address, which is then allocated to your device and allows you to get into the system. So DHCP is something similar to, okay, so you go to a hotel and you go to the receptionist and you pay cash or pay money, and then they tell you, okay, let's say if Ethan goes to a hotel, then they say, thank you, Mr. Ethan, this is your key. You can go to your room, and you will be allocated, so that receptionist will allocate a certain room under your name. So you can basically get that number and you can go to the room, right? So similar to that, similar to the process of a hotel, DHCP gives you that particular IP address. So then it will basically make sure that you have the particular connectivity which is there. Okay, so what happened was, now this particular IP address allocation, the problem is, now let's say when we have so many devices, the number of rooms ran out. Similar to the hotel, let's say if your hotel has only 100 rooms, and if you get 100 guests, the 101, when you get 100 and like the next guest, the first guest comes after having all the 100 rooms occupied, then you don't have enough space. So that is where we basically got into this particular IPv6 version. Okay, so what happened was we have a limitation of 5 billion, almost 4 billion device limitation for IPv4, and the internet users basically climb very slow. But the problem was not the internet users, because for us we can have dynamic IPs, right? දැන් මගේ IP එක තව කෙනෙකුට use කරන්න පුළුවන් මම පාවිච්චි කරන්න නැති වෙලාවට. But the problem is the number of devices went up. So each and every device, everything is connected to the internet, right? Now, example, if you take me right now, I have my 2 laptops, my phone, and my watch. So altogether, only just inside this room, I have 4 devices, which is connected to the internet, right? So that means if we count it like this, we have billions and billions and trillions of devices. So that basically ran out of the number of limit of IPs which IPv4 was available, was giving out. So that's why we got into the IPv6 thing. So I hope you got the idea about DHCP and the IPv4 and v6. Just a brief idea. We'll talk about this extremely in depth on how it works later on. Okay. So if we take something like this, so here we have 2 devices. Okay. Now, if you look at this example, you can see we have this device, and when you basically try to communicate between 2 locations, it's basically having an address. So IP address is same as having a physical address. So from this location, you are connecting to the internet. Okay, but here we have a problem. Now, in Sri Lanka, we do not get actual IPs allocated to our devices on regular basis. Okay, so it's like this now. Okay, podi වැඩක් තියෙනවා. Then if you take a different country, let's say US, when you connect to the internet from one of your devices, what happens is you are getting allocated with a unique IP address. Right? And then when you type what is my IP, if you are in US, you can get a pinpoint location. අපි ඔය ෆිල්ම්ස් වල දකින්නේ මේ IP එකෙන් track කරනවා කියලා they basically show you on a map and they find the exact location and go and catch the thief or the bad guy, right? So now in Sri Lanka, that's not actually practically doable, because here we as you guys saw when I showed you guys these undersea cables and all, we do have only a couple of connections which is getting into Sri Lanka. So because of that reason, our locations are not that accurate, right? But now in other countries, they do have different types of IPs which will basically give a proper clear location. So example is, if you take this one, like you might have different devices connected through different locations to the internet, and they can actually communicate between the locations through the IP addresses. So even when we create a server, what happens is the server gets allocated a specific IP address like this, and then what you do is when you connect through the internet, you access this IP address. Okay, I think you guys might have noticed, like sometimes when you go to a website or click on a link on YouTube, Google, sometimes you end up going into IP addresses without having an actual domain, right? I think you might have seen that as well. So the IP address will actually give you the direct access to the server. So far, is it clear, guys? Any questions? Too complex there? Do you want me to explain the concept back again? Ethan, is it okay?
Yes, sir.
Okay, I hope. Okay, if you have any questions, ask. So we'll be talking about the IP calculations in a while. අපි ඒකට යන්න කලින් එතන පොඩි binary calculation එකක් තියෙනවා. We have couple of bits of calculations and we can go through it. But before that, we just need to learn the basics. Hari, okay. And what about Dinal? Are you on track?
I can hear you properly.
No. I mean, are you okay? Everything clear so far?
Sir.
Okay. What about Azman? Are you okay as well? Any questions? He seems to be mute. Okay. So I wanted to make it clear that you guys know this because before we jumping into MAC address. Okay. So then we talk about the primary point of identification of a device, which is known as the MAC address. Okay. So now IP addresses, as we discussed, IP address is actually getting allocated while the time you are connecting to the server, right? When you're connecting to the server, connecting to your router or your whatever the network, your router or the network switch provides you the IP address. Now, MAC address is something different. MAC address is a universal identification code which is built to identify your particular device. Okay, so let's try this out. Ethan, can you have your phone with you?
No, sir, I'm not having.
Huh? Yeah.
I am not having a phone.
Oh, okay. What about Dina? Do you have a phone with you? Okay. Now, perfect. So in your phone, go to hold on. Go to settings and go to general. Hurry.
Sir.
General and click on about.
Yeah.
Okay. And give me 1 second. Okay. Network. Hold on, I'm trying to I'm trying to find the we have the Bluetooth, we have the okay, so this OS is different. Give me 1 second. Mac address in iOS. You are using the latest iOS version.
Yeah.
Should be, no?
18.219.
I'm trying to. Okay, yes, okay. So, let's try this out. So, this MAC address is something. Let me switch the screen just for the moment, just to show you guys how it looks. How it works. Okay. So, here when you go to settings and about, you have something known as the Wi-Fi address, right? Harry, can you tell me the Wi-Fi address?
Of
In your settings, you do have something known as a Wi-Fi address.
yes, sir.
Ko කියන්න බෑ number
4C
4C වෙන්න බෑ. මම කියන්නේ මෙන්න මේක. මෙන්න මෙතන තියෙන එක මේක. Wi-Fi address. පේනවද? අන්න හරි. Yes. Yeah. කීයෙන් කියන්න බලන්න 4C. හරි? Okay. Yeah. Cool. Okay, let me
97. Yeah, 4C 97.
4C 97.
Double C
Okay.
9A.
Okay.
59.
Okay.
8.
A8. Okay. So your phone is manufactured in 2023, no? Your phone is manufactured in 2023, and you have a start address, and see, you have a vendor, you have a country code, as well as you have some address details. Okay, so let me show you something. Check iPhone device with MAC address. So there are how to locate physical address, iPhone MAC address checker. Let's try this out. So if I enter the MAC address and check MAC, to take a bit of time, and so it's still verifying. Yeah, what is your phone? You bought it last year before last year, 2023.
No, sir. 2024 I bought it.
Okay, but that's a model from 2023, no? Yes.
I think
What is it? Is it a 14 or a 15?
13.
13. 13 and 2023 දාවේ නෑ නේද? It was before that, right? This is not getting loaded. Ayyo. Okay, let me try this out again. Verify. I have some sort of issue. So basically using the ME. Okay, so this is what I want to show you guys. So the MAC address, and we have the ME code in our phones. So the MAC address is actually something similar to a universal address. Okay, so let's say if Ethan wants to create a new phone or a device, then you have to actually register that in the international registry itself, where all this information should be reported. So the MAC address, since it's unique, each and every iPhone which came out in 2023 has a unique MAC address to that. So the MAC address has a prefix which is 4C97CC, 4C97CC, which is the address prefix which will tell us who's the vendor and which will tell us the details about the company. Okay, and then the rest of the address is basically where it would be mentioning it would mention who this or what this device is. Now here in this case we can say this MAC address was created back in 2023 November 4th. So this is not getting loaded. I'm not sure why. There's a problem with this okay, let's try out something else. We had so I can't exactly find that. There was a website where it actually showed us the model of the iPhone. You just need to you just needed to add the MAC address, and that was it. And it literally showed the actual model of the iPhone as well, when it was released, and so on and so forth. So I think it's this site, but I'm not sure why it's not loading up. Let's try it again. I will get this Cloudflare validation. There's a bit of a problem with Cloudflare, it seems. So yeah, anyway, so just to give you guys a clear idea about this. So yeah, it's not getting loaded. So this is how it works. So the MAC address is basically a unique address which is created using certain set of points. Okay, so here you can see the MAC address usually is made up of 6 pairs of characters. So the first 3 points, first 3 points of the characters, or the first 6 characters, they are focused towards the manufacturer. So it specifically says this belongs to this particular manufacturer on this particular date. Okay, and then the rest of the 6 pairs are basically there to find and assign or to basically define the specific address. Now in this case, the NIC is basically the network interface card, the network connector card we use. So we used to connect to the network. So this NIC part is the next 3 sections. So this will be basically sent out when you want to connect to a network. Okay, so how it works is, now when you basically connect with a router, as I said, the router is actually sending you a message saying that okay, you can connect. Right? So when you say hi to the router, what you send is this MAC address. So you send you go to a station and you give your ID. It's similar to that. So you basically give your ID to the router, which is this one, and at the time when you give that ID, that MAC address is being sent to the router or to the switch, and then the MAC address will be used to identify you throughout the entire session which you use, or session which you will be basically working on that network. So when the details figure, so this MAC address is actually something very sensitive. It's like this. Now if I join a network, let's say අපි දෙන්න මයි දිනාලු ඉන්නවා කියලා මේ public network එක. If I get to know Dinal's MAC address, I can literally get into his PC. Without doing anything, I can literally hack into his PC, and I can do some spoofing, and lot of things can be done within the network. Example is, let's say if me, Dinal and Ethan is on the same network, if I know Dinal's MAC address, I can send a message to Ethan with Dinar's MAC address so that Ethan's PC will think it's Dinar. මං ඊතන් එක chat එකක් දාලා ඊතන්ට message එකක් දාලා අඩෝ කියලා බයිනවා. බයින්නේ ඒක බයින්න පුළුවන් by using Dinar's MAC address. ඒ වැඩේ වුණා මූව තමයි අහුවෙන්නේ අන්තිමට. ඔය වගේ. So that's why your MAC address is very sensitive and there are multiple issues which you can actually get into problems if this MAC address is leaked. So now, usually networks, they actually lock these MAC addresses, so they don't allow to send it out. But at the same time, if your MAC address is if your MAC address doesn't have access or your access is blocked, then that is, of course, it will not let you access the system. Example is, so අපි කියන්නේ මේ අපි වචනයක් තියෙන network වලින් block කරලා දානවා කියන්නේ මේ so basically you can do that as well. So if you access your router's backend, I will show you guys how to do that next time. Router එකේ backend එක access කරන්න මම කියලා දෙන්න. So when you can access your router's backend and you can see all the connected devices. Let's say Ethan wants to block out his brother from the network. You can log into your router's backend and you can find his device and you can block that device. So if you block it out, even if he has access to the username and password, everything, the network will not give him access. The network will say, no, I'm not going to let you in because you are in the blacklisted list. Okay, so that is how you block somebody from a network. At the same time, they do like some, let's say some Wi-Fi hotspots and all, they actually provide access to any sort of they basically give out a specific device name. So you use the MAC address to identify the device on the network. So if you open up one of these routers and all, you will actually see the device name listed in the list in the back end, which will then allow you to find out who this is. And at the same time, tracking a device. So MAC addresses, since when the device is connected to a network, now using the MAC address, they can track. So that's the very basic idea on how they track your devices. So it's now example is once we connect to a let's say 4G or let's say to any cellular network, our device has a MAC address, no? So that MAC address is being sent to that cellular network and that is connected from there. So the worst comes to worst, what happens is, since it's connected, they can track us using the MAC address. ඔය මේ එහෙම තමයි ඔය කියන්නේ මේ ලංකාවේ වුණත් ඔය track කරන්න කියන්නේ මේ they found the phone number and they say that they tracked him to his location. That's how they do it. So immediately now, let's say if Dinar's phone number, if I know Dinar's phone number, then apita karanna bෑ, we can't do that. But if we get that into CID or someplace, then they can actually request the carrier to find your location. ඩයලොග් එකට කෝල් එකක් දීලා මම කියයි මෙහෙමයි මෙන්න මේ ෆෝන් නම්බර් එක හවල් තැන ඉන්න කොහෙද ඉන්නේ කියලා හොයලා කියන්න කියලා. Dialog can go through their network logs and find out where your MAC address is connected. So then they can literally pinpoint your location. And at the same time, the final case is assigning IP addresses, so fixed IP addresses. So each time when a device connected to a network, it is identified from the DHCP server, usually using its MAC address. So when it identifies using the MAC address, then it's given a IP address to the device. And the fun part is, let's say when the device again connects to the network, let's say you got disconnected and you connected it back again, then also the router or the switch or whomever wherever the place the DHCP server is running on, it will identify that you got connected to the server before, and it will automatically uh, let you let you access. Okay, so one final point, which is known as the spoofing. Make a time on if I can get access to someone else's MAC address, then I can spoof that person. I can send messages behalf of that person, and it can do some damage, because inside a network you can log in, and without even nobody knowing that you are there, you can play around and do some stuff in it. Okay, perfect. So yeah, one last point, we'll just go through this and then we'll call it a day. So the final method of identifying is using the device name. Okay, so a device name is basically a descriptive name that will help to identify the computers in the network. So example is each one of your devices, like all of your laptops, they do have a device name. ඒක automatically assign වෙනවා device name. Most of the time, like if you take Linux and Mac machines, it uses your username as the device name. But in Windows machines also, while at the time of installing, it will basically add a name into the system itself, and it will use that particular name to show you in the network. Okay, and this means that will basically make sure that the device names are visible. But there is a problem. Device names are basically used by a single device name can be used with multiple computers. අපි හිතමු මේ අපේ network එකේ හිතමු we have an office, and in our office we have 3 guys with the name as Dinal. දිනාල්ලා 3 දෙනෙක් ඉන්නවා කියමු. දැන් හරි ප්‍රශ්නේ. හරි. දැන් එතකොට 3 දෙනාගේම machines වල තියෙන නම තියෙන Dinal කියලා. Then that means that would basically introduce some sort of a conflict, right? So that is actually a problem, and what you do is you can actually change, you can have the different names, and then you can basically make sure that from the operating system itself it is sorted out. So in my previous office, if the management gets a person with the same first name, they don't let them use the first name. They ask them to use a second name or a different name based on the system, because you can't have 2 machines with the same name. Either you add a prefix or something similar, and then you basically use it. So okay, perfect. So we started networking and we went through up to the device names. And during the next class, we'll talk about the components of the wireless networks, and we'll talk about basic ideas behind the networking and how these access points and these things work. Okay, so yeah, so guys, before we wrap up, when can we have another class? How is your schedules? I can always do a recording and upload, but I really want to do it live, so that if you have any questions, you can ask